In section 2.4, we're using equations to solve word problems. So below you'll see a list of steps that you should use to help solve word problems, because we know that's everybody's favorite thing to do. So the first thing you want to do is understand the problem. This is one of the hardest things for students to do. So read the word problem carefully to get an overview. You're going to determine what information you will need to actually solve the problem. If necessary, you can draw a sketch and label it with known information and determine what needs to be found. You'll choose a variable to represent one unknown quantity, and if necessary, you'll represent other unknown quantities in terms of that same variable. Once you understand what the problem is looking for, then you're going to write an equation. So you're going to look for keywords to help you translate the words into algebraic symbols. You'll use a relationship given in the problem or an appropriate formula in order to write an equation. Once you write down the equation, we're pretty comfortable with solving them, so you'll just solve it and then state the answer. And the last thing you want to do is check it. So check the solution in the original equation. You want to be sure that the solution to the equation actually answers the question in the word problem. You may need to do some additional calculation if it does not. So let's go ahead and put this to the test. Example number 1. Nancy works for an educational services company that provides computers and software to local public schools. She went to a local truck rental company to rent a truck to deliver some computers to the Newbury Elementary School. The truck rental company has fixed a rate of $40 per day plus 20 cents per mile. Nancy rented a truck for 3 days and was billed $177. How many miles did she drive? So let's see what is actually important in this problem. So honestly, I don't care that Nancy works for an educational services company. So we can go ahead and cross that out. She went to a local truck rental company to rent a truck to deliver some computers to the Newbury Elementary School. This is just miscellaneous information. We really don't need to know what she's delivering and to where. What we care about is the fact that the truck rental company has a fixed rate of $40 per day. And then plus it's 20 cents per mile that they drive. Nancy rented the truck for 3 days. And so that's going to take into account that $40 per day. And we know that the total amount that she was billed was $177. We want to know how many miles did she drive? And so that's what the question is asking. That is what you want your variable to be. So I am just going to say we're going to let x, or whatever you want it to be, we're going to let x be the number of miles driven. That's the goal. That's what the question is asking for. Now I want to set up my problem. So Nancy rents a truck for 3 days, and this company has a fixed rate of $40 per day. So that means that you're getting charged $40 a day no matter how many miles you drive, whether it's 0 or 100. That flat rate will always be there for every day you have the truck. So because she has it for 3 days, that means we are going to have $40 times 3. That takes care of that flat rate. But you also get billed 20 cents for every mile that you drive. And so that means that the 20 cents times X, because that's the number of miles that she drove. We don't know how much that is yet, is what is going to get tacked on to that bill of the fixed rate. We know at the end of this entire thing, she was billed $177. And so now that we've set up our equation, we want to solve for X. So the first thing is, let's go ahead and multiply that 40 times 3. That's going to give me 120 plus 0.20x equals 177. We can subtract 120 from both sides. So we can get x by itself. And so on the left-hand side, it's going to cancel. And we're left with 0.20x equals 57. But we want just x. We want to know how many miles she drove. And so we're going to divide this by 0.2 on both sides. And so it cancels on the left. We end up with just x, which is what we were looking for. And so x is equal to 285. And this is going to be miles, because that's what x was supposed to be, how many miles she drove. You can always plug this back into the equation that you were given to make sure that you actually come out with that $177. Let's try example number 2. The ACETONES are a barbershop quartet. They travel across the country in a special bus and usually give 6 concerts a week. This popular group always sings to a sellout crowd. The concert halls have an average capacity of 3,000 people each. Concert tickets average $12 per person. The one-time expenses for each concert are $15,000. The cost of meals, motels, security, and sound people, bus drivers, and other expenses total $100,000 per week. How many weeks per year will the ACETONES need to be on tour if each member wants to earn $71,500 per year? All right, that's a lot of information. So this problem deals with income and expenses. So let's look at the income portion first. And so I'm going to highlight that in pink. So we know that they give 6 concerts a week. And they always sing to a sellout crowd. The concert halls have an average capacity of 3,000 people each. And their tickets cost $12 per person. That is how much they're making from each and every show that they do. So let's do the income and figure out how much they're making. So if they give 6 concerts a week, and at each concert there's about 3,000 people, and they pay $12 for a ticket, then they are making $216,000 from their income. Now let's talk about their expenses. So I'm going to highlight this in blue. That 6 concerts a week is going to come into play again. The one-time expenses for each concert are $15,000. So every time they have a concert, they're paying $15,000. But also, in addition to that, the cost of the meals, the motels, the security sound people, all of that stuff, that goes to $100,000 per week. So for their expenses, how much they are spending for each concert to happen, we have 6 concerts a week. They cost $15,000 every concert, plus an additional $100,000 per week. And so that means that they are spending $190,000 a week. And that's the same thing for the income. They are bringing in $216,000 a week. The question is, how many weeks per year will they need to be on tour if they all want to earn that $71,500? So I'm going to let X be the number of weeks. On tour. So let's go ahead and set up our problem. So we know that we're pulling in $216,000 a week. So we don't know how many weeks, so 216,000x. And we need to subtract the expenses, which is $190,000 a week, times X. And this is equal to 26,000x. So that's how much profit they're making. We want to know how long this is going to have to go on for so that they make $71,500 per year for each member. Well, this is a quartet, which means there are 4 of them. So if 4 of them want $71,500 apiece, that means that we need to set this equal to 4 times that $71,500. And so what we end up having is 26,000x equals $286,000. And so we can just divide by $26,000 on both sides. And so we get X, which is the amount of weeks we will need to be on tour for this to happen. And 286,000 divided by 26,000, that gives me 11 weeks. So they need to tour for 11 weeks for the entire quartet to each get $71,500 per year. That's a pretty nice chunk of change. And the last example. An astronaut's spacesuit contains a small rectangular steel plate that supports the breathing control valve. The length of the rectangle is 3 millimeters more than double its width. Its perimeter is 108 millimeters. We're going to find the width and the length. So what's important in this problem? The fact that it's a rectangular steel plate is going to come into play here. We know that the length of the rectangle is 3 millimeters more than double its width, and the perimeter is 108 millimeters. What we're looking for is to find the width and the length. So I'm going to let L be the length and let W be the width. Let's go ahead and draw a diagram. Anytime we talk about shapes, I feel it's helpful to draw a diagram first. So we have our rectangle, and we know that the length of the rectangle, which is right here, is 3 millimeters more than double its width. So that means we have 3 millimeters more, 3 plus, twice its width or double its width, 2W. And the length is going to be the same on both sides. So L is 2W plus 3. And the width is just W. We don't have anything about that side. We know that the perimeter is 108 millimeters. Well, the perimeter formula just means that I'm adding up all of my sides. So length plus W plus length plus W. But we can combine like terms. We've got 2 L's and 2 W's. And so the perimeter ends up being 2L plus 2W. Well, we know the perimeter is 108 millimeters. Our length, or the L in this case, we can substitute as 3 plus 2W. So wherever we see L, that's what we're going to write down. So 2 times 3 plus 2W, and then plus 2W. And so what we need to do is let's distribute the 2 to both pieces. We've got 108 millimeters equals 6 plus 4W plus 2W. Now we can go ahead and combine like terms on the right hand side. We've got 4W and 2W. And so we have 108 millimeters equals 6 plus 6W. Let's go ahead and get W by itself. We're going to subtract 6 from both sides. And so on the right hand side, the 6's cancel. We end up with 102 millimeters equals 6W. And the last thing we can do is divide by 6 on both sides. And so the right hand side ends up canceling with the 6's. And we end up getting W equals 17 millimeters. So that gives me one side, but I still need to figure out the length. And so to figure out the length, we're going to come back over to our diagram where we said L equals 2W plus 3. And so we can plug in our W, which is 17, and we get L equals 2 times 17 plus 3, which is going to give me 34 plus 3, which is 37 millimeters. So our length is 37 and our width is 17 millimeters.